Namaste, welcome back to Sitapragna channel. You are watching AWS Cloud Projects for Beginners to Expert playlist series. And so far, we have finished 6 seasons. And in each season, we did projects in a different role, as you can see. So we did it in Cloud Practitioner, Data Analytics, Networking Solutions Architect. Why do I see one project? Did they add a new project in there? And then serverless developer, and then security. So those are those 6 seasons, and this is the final season, season number 7, where we are going to do projects as a machine learning engineer. So far, the 6 roles, we did 80 projects. I think, is it exactly 80? Let me check. Okay, it's not 80, it's 79. I don't know, for some reason I numbered them incorrectly. Okay, then that takes us to 93. That's fine. We have so far finished 79 projects. If you haven't watched, go ahead and watch them. Let me know if you enjoyed those projects or not. In this one, we are going to do 16 more projects, and I will check this one. Did they add one in each of these? I don't know. Okay, so let's go and hit the machine learning, and as you can see, the assignments are going to be all these, and let's click choose. Yes, we want to change our role to machine learning. Okay, it is choosing that. Once it chooses, each each of those roles has a separate island, and as you can see here, and we will have a machine learning island as well. I don't know where that is. That being said, let's go ahead and do our first project, which is going to be image and video analysis. Okay, if you are new to this channel or if you are new to this playlist, this is a role-based video game. As you can see, we can play the game in different roles, and this series is going to be we will be playing as machine learning. Okay, so this is the machine learning island. So how it works is we have different NPCs. Each will give us a certain project, or they have some kind of situation in at their work. So that is displayed with this exclamation mark. If you're already a gamer, you already know what this means, which means they have a quest. We go and we'll accept the quest. Let's see what this quest is about. And each quest or the project title is displayed here. So they are going to explain their problem, and as a machine learning engineer, we are going to give them a solution. And sometimes they will ask us to build a demo version of it. Sometimes they will ask us to implement the solution, then we will do it, and then they will deliver it to them. So how do we do it? We will have a lab, and in that lab we'll implement it and give it to them. So let's find out what is going on. Hello there. I work at the space administration department. We have a unique case. Can you help us? Sure. What is your case? Well, we get regular random alien visitors in our airspace, which disrupts our flight patterns. We would like to automate a process that can identify when alien spaceships show up. We want to sound our alarms sooner. Can you suggest a solution? That really is a unique case. Do you have digital proof of these alien visitors already? Oh, yes. We monitor the sky 24/7, and our surveillance cameras have gathered a huge collection of still images. So huge, in fact, that it's unrealistic to manually go through each image and identify the incidents. Awesome. I think Amazon Rekognition can solve your problem. The service offers pre-trained and customizable computer vision capabilities to extract information and insights from your images and videos. Amazon Rekognition Image is a deep learning powered image recognition service that detects objects, scenes, and faces. Amazon Rekognition Image also detects scenes within an image, such as sunset or sun or beach, so you can quickly search, filter, and curate large image libraries. That sounds really interesting. Okay, so Amazon Rekognition can search our images for us. Can we automate the identification process as soon as the image is taken? Definitely. You can combine other AWS services with Amazon Rekognition, such as S3 and Lambda, to automate the detection process. That means we can sound our alarms sooner, but our engineers are not familiar with the technology. Will you help us create a proof of concept for our spaceship alert system? Of course, I will. Thanks for helping us. Okay, so if you if this is your first video, in my previous videos I have already mentioned I am so excited about this particular role because I am not a machine learning engineer in my at my work, but I am planning to move towards machine learning and AI. That's the reason I'm so excited about this particular role, because whatever I'm doing as part of this project is completely new to me. Even some of them, for example, previous season was about networking. In networking, I'm familiar with VPCs, etc. But most of the advanced topics that we did in the previous season, I'm not aware of them. But this one is complete unknown territory for me, and I'm excited because offline I'm also preparing for this. I'm preparing for statistics and learning R and Python, and then once that is done, I'm planning to move towards machine learning, etc. So I'm interested. If you are, stay tuned till the end of this particular season. All right. So what are we going to learn after finishing this project? We will learn how to use recognition to detect objects in an image. Then we will create a Lambda function to be invoked by an S3 event so that it can be automated. So let's click on start. Okay. So once we accept the project, they will show us the diagram and it will explain what we are going to do as part of this project. And one awesome thing I like about it is the video concepts. So whichever service we are going to use in the projects, they actually have videos pre-recorded for us, which will walk us through the service, about the service, its features, benefits, and etc. I would recommend you to watch these videos because they are a fun way to learn about these services. And without knowing that service, if you jump into the project, you won't understand much. So I would recommend you to go watch it. Okay, I'm not going to play them here, but you can find these videos in our playlist, which will pop up here. After clicking on it, it will take you to AWS tutorials for beginners playlist, and search with this title in that playlist. You will get the video, watch it, then come back to the project. This solution uses recognition to analyze images and detect specific objects. Amazon Recognition automates your image and video analysis with machine learning. It can identify objects, people, text, scenes, and activities. A label is an object, scene, action, or concept found in an image or video. You can use the detect labels operation to detect labels in an image. A user uploads an image to the input folder of a bucket in S3. This put event invokes an Lambda function, which we have learned how to implement this in several projects. Lambda calls the Amazon Recognition API to detect labels in the image. The labels found by recognition are returned with a confidence score so that you can make informed decisions about how you want to use the results. Lambda verifies that the specific labels are found. The image analysis results are stored in S3 bucket output folder. So basically that's what we are going to do as part of this project. And whatever we just discussed is usually divided into two parts. One is the practice lab goals, another one is DIY. As part of practice lab goals, they are going to tell us what to do step by step. And what are we going to do? We are going to use recognition label detection to identify and label objects in a simple image file. Then we will configure Lambda function to invoke recognition to detect and label objects in an image. Then we will configure S3 by adding an event notification to invoke the Lambda. Then we will validate the received responses JSON in the S3 bucket. And then the second part is DIY, wherein they will ask us do this, then they won't tell us how to do it. So we will do it on our own. So what are we going to do as part of DIY? We will update the Lambda code to detect a new label, spaceship, and then we will upload the sample spaceship image to S3, which will trigger this and which will label it. Then we will validate the response JSON file received in this bucket. So let's go ahead and start our practice. Okay, so let's start the lab. Sometimes it will take some time. And in the lab file section, there will be some files that they already provide us. As you can see, there are three images, one airplane, horse, spaceship. And then they also provided us the lambda code for us so that we don't have to sit here and write the code. Instead, they're providing that for us. I will walk you through the lambda code as well. Each of these steps will have concept related to what we are going to do here. Most of the time I won't read it, but I would recommend you to pause the video and read it and then move on to the next step. So it's talking about downloading the files, which we already did. Then it's asking us to go to recognition. Using recognition, you can add image and video analysis to your applications, provide an image or video to recognition API, and the service can identify objects, people, text, scenes, and activities, which they call labels. It can detect any inappropriate content as well. So that, for example, if you have a app where you let users upload pictures, but you don't want them to upload uh, indecent content, right? So then you can integrate recognition into your app, wherein it will check before it actually uploads the image to your app. When a user tries to upload it, recognition first checks it and it sees if there is any inappropriate content. If so, then it will flag to your app. Then the flag will decide not to upload it, complaining, saying it has inappropriate content. Right? There are so many use cases where you can use recognition. I think one of them I mentioned in one of the other video, wherein let's say you have a camera, right? Most of the people have a camera these days at their door. So what you can do is you can integrate recognition with your camera, and what you can do is, let's say you have your family, right? Family and friends. And if you want to let them enter your house without having a key or something, if you have set up automatic unlocking mechanism to your door, you can plug in recognition with your camera. Once they come in front of the camera, you already uploaded their images into your recognition etc code. So what it does is, when it looks at them, it will it will figure out who it is. Then it will check that your code will get that value. Then it will validate if it is a person you authorized or not, and then it will open the door for them. One use case is that. Or you can integrate recognition and maybe put something like, if some random people, if they are coming in front of your door with weapons or any such things, you can write your code and say, like, whenever that happens, immediately um, inform me, etc. Right? There are several use cases you can think of, like if there is a mailman that comes with a package, you write your code in such a way that recognize a box that he's holding or something, and then maybe send an notification or message to your phone. Several use cases. I'm not going to explain you all of those, but okay, let's open that image. Okay, once we are there, I think is this the image they uploaded, or okay, I think this is the image they uploaded. Let's see which image they uploaded. Airplane, but this is not an airplane image. Okay, anyways, I think these are samples. I don't know. So once we click on the label detection, I think this might be a sample image. As you can see, this is all it is detecting automatically. Like, it's detecting car, automobile, vehicle, because you can, those are like synonyms. Transportation, person, because there is a person or a human, and maybe skateboard, buildings, etc., trees. It will detect all those things. Okay, so anyways, this is for the sample. We can review, and then let's click upload, and let's upload our airplane. Amazon Rekognition is based on the same proven highly scalable deep learning technology developed by Amazon's computer vision scientists to analyze billions of images and videos daily. It requires no machine learning expertise to use because they already created it for you. So this is the image that we are uploading. So once you upload the image, you can see the results. Airplane, how much percentage, aircraft, vehicle, transportation, flight, airliner, and XYZ. A label or a tag is an object, scene, action, or concept found in an image or video based on its contents. For example, a photo of people on a tropical beach might contain labels such as palm tree, beach, running, and outdoors. See, this tree is an object, beach is a scene, running is an action, and outdoors is a concept. So it can detect all that. Okay, now once we do that, I think we just did expanded. I think they just expanded the request part. You see the request and response here. The request part, they are just asking us to review, and the response will look something like this. Labels, name of it, how much confident it is about what that label it labeled. Instances, it is telling which box, where does it see this one on the picture. You pass the input image either as base64 encoded image bytes or as a reference to an image in an S3 bucket. For each object, scene, and concept, the API returns one or more labels. Each label provides the object name and the level of confidence that the image contains the object. Okay, so basically, I think recognition is it's that simple. That's why they are recommending us to use, because we don't have to write that machine learning algorithm behind the scenes. It already does that for us. So let's go to Lambda and let's create the function. They gave us the code. We will use that code to create the function. And let's name the function lab function. Okay, so let me write that down so that I will be consistent. And the runtime we are going to choose is 3.8, and it's going to be 64-bit or both. And let's scroll down. Okay, and then we are going to use an existing role which they already created for us. This role is called execution role. When it executes, first of all, this execution role by default will have access to CloudWatch, but if you want to access anything else, for example, triggering the recognition, right, that those permissions will be as part of this role, which they already created. Then we will create the function, and you will go here and you will import the zip file which has the code and etc. libraries etc. which I downloaded. I will walk you through the code once I upload it. If the code is larger than 3 MB, or if you need to add libraries or for language that the editor doesn't support, you must upload your function code as zip archive. If the zip file archive is smaller than 50 MB, you can upload the zip file archive from your local device. If the file is larger than 50 MB, upload the file to the S3 bucket. Usually your code won't be that big. And if it has so many libraries, they will ask you to store them as layers. Each layer can support up to 250 MB. Okay, that is your file, and label is airplane. They want us to type label as airplane because that is what we are interested in, right? Uh, we might have several labels, but the label we are interested in is airplane, so we are hard coding that there. I will walk you through this when we actually import it, review it, scroll down, scroll, click deploy. Okay, deploy, then let's go to configuration, edit it. We are going to change the timeout from 3 seconds because obviously I think it is going to take more than 3 seconds to 1 minute. And then let's save it. Then let's go to code again, edit, runtime settings. Okay, what are we doing? Handler, type index.lambda handler. You are replacing lambda function.lambda handler with index.lambda handler. Why? Okay, that's interesting. I don't know. I have never done this. Oh, I created so many lambda functions, but I didn't do it. This one. See, there is always something you can learn, right? Let's click save. Did they explain why we did that? Let's see. A function handler can have any name. However, the default name in the AWS Lambda console is that. This function handler name reflects the function name and the file where the handler code is stored. Oh, because they named it index, that's why they are changing it. Okay. Then let's go to S3 and let's create a bucket where we can store these labels. And this has, as you already know, this has to be a unique bucket. And where are we creating it? North Virginia. We will select ACLs enabled and object writer. Then we are going to leave the SSES3 and then bucket key. We are going to enable it. Then let's create the bucket. Let's go copy it and let's create a folder. Which is called input. Okay. Are we storing our images here? Maybe. And output as well. Okay. I thought we are going to use the bucket they already created it, but maybe not. Let's click on properties, create event notification, which we have done in several projects as well. So basically what this do is whenever whatever event you are going to pick, when that happens, for example, when somebody puts a file in the bucket, you can trigger something else. So we are going to trigger lambda in this case. So we are going to name the event that one, and prefix means we are telling it to only if something, whatever the event that I am going to pick happens in this particular prefix, then do it. And we are saying suffix JPEG means even if input has other files, only trigger this event in case if it ends with a .jpeg. That is what this is saying. And the event type they will pick is obviously put. When somebody puts a file into input folder that ends with JPEG, this event gets triggered. And then you have to set what is the destination. Okay, you pick the event, but when that happens, what do you want to do? I want to trigger a lambda function. Which lambda function? The one we created. Pretty much that's it. Now we are uploading both the, oh sorry, we are creating another one, just the same but PNG as well. Okay, here we selected .jpeg, same thing, PNG files as well. Okay, then we are going to go to import and upload the files that they gave us. Okay, so they gave us three files. One is horse, then there is another one spaceship, I guess. That's it. They want us to upload only one. Okay, maybe as part of DIY they want us to upload the spaceship, I guess. Okay, that's fine. Which we will do. Then let's go back to the bucket. Let's click output. Okay. Oh, I think that when we uploaded the horse file, it triggered the lambda function. Then the lambda function used recognition and labeled that image. Then we got the response back here. Then we'll download. If we open it, it will show label horse, animal. Failed airplane. Oh, okay. Since we remember the name airplane label, it's saying airplane not found in the horse. But what did I find? A person. Maybe there is a person in there and human, and I guess it will also show us um, horse and etc. We can take a look at it. Now we are going to upload airplane image. Now it will say yes found. Obviously, I think if I open that, yeah, success airplane found because this is the airplane image. Makes sense, right? I think pretty much that's it. It's basics, but at least we now know how to integrate recognition into our code. Now let's go ahead and do it. Okay, cool. I hope one of the project will let us write our own code instead of already using predefined ones. Okay, let's go to recognition. Okay, we need to recognition, we need S3 and we need lambda. What is this? S3? This is lambda. This is recognition. Okay. Let's go and click label detection. This is what the sample, right? You can see neighborhood, city, road, street, urban person, car, transportation. It says sedan, which is only 55%, path, license plate 55 because It can only see a little bit. 55% motorcycle. I didn't even see motorcycle. Where is that? Do you guys see motorcycle? Maybe that one? Did it detect that one? And how much confident it is about it? 72%. I am like, wow, that's awesome. Shoe makes sense. Footwear, wheel architecture. Yeah, if you click on this, yeah, obviously architecture, buildings, cityscape, urban, metropolis, water. Yeah, duh. Boat. Do you guys see a boat anywhere? I don't see a boat. It is 94%. Wow. Um, is this the boat? Yeah, wow. Good for it. Tower, okay. Nature, I don't see any nature. Where is this? Can I see that nature? Is it calling this nature? Okay. Scenery, okay, fine. Yeah, we get the idea. Now let's go ahead and upload our. Okay, here I uploaded it. As soon as I uploaded it, you can see aircraft, flight transportation, airplane, airliner, bird. Where's the bird? This is ridiculous. It is it calling where is the bird? Huh. I don't see a bird. Is it calling this a bird? Animal, takeoff, landing jet. I don't know. Anyways, it did they do that. Then let's go to request. Okay, image bytes and response. You can see aircraft. It is that much confident. Instances, for some reason, it is not showing, but that's fine. Parents, transportation vehicle, and so on and so on. Okay, these guys are we are doing. Why did we do this? Just to see how it does it. But this is manually. I am me picking a picture and not. But most of the time we don't do that, right? Our code has to do this. So that is the lambda which sends it to the which calls this service recognition within lambda. Then it gives this picture from S3 location. Then it will spit this out and it will give back to lambda. So that's all is going on behind the scenes. And now let's go to lambda. Let's create the function from scratch and we are going to name it this one. And we are going to use Python 3.8 and that is the architecture. Default role we are going to change it to existing role and let's pick come on up, let me move this, then I will get it, I guess. Yeah, this one. Let's click advanced. Okay, we are not going to select any of those, so let's create the function. We can close this, I don't need that. Okay, we have it. This some constant issue I'm having with lambda. Okay, there won't be any code here. This is the sample code because this is the handler, but we can upload from the zip file that they gave us, which I will do in a minute. Okay, we have the file here. Let's save. So it will import the code into this file, into this function. Okay, let me open it. And as you can see, since it's index.py, we have to change the handler name. Usually it is lambda underscore function, I guess. So if you see, we are importing Boto3, logging and all that. We are logging, that's what it is doing. And this is where we are going to put our label, which is airplane. This is just telling it if there is some code below. If it finds the airplane in the picture, then send a message. Okay, we are using instantiating the S3 client. And as we know, this is the main function of the lambda. So whenever lambda is triggered, code within this function gets triggered. This is logging as info, then bucket. You are getting the bucket as input. What is the thing that is triggering the lambda? S3 event. So the S3 event will contain these details like the bucket name, the bucket key or object key. Okay, so those two are our important things because Lambda should go and get that image. And then we have the output key. So why we need this? Because we have to store our results, the JSON results that Rekognition gives us. And then we are preparing a response saying status not found body. This is used for when we try to find if there is airplane or not. Now we are instantiating the Rekognition service from within Lambda using Boto3. And then what are we writing code here? We are saying from this particular client, there is a method called detect labels, which takes image or what is it, base 64 content. Now we are just telling it, I'm giving an image to you, not a video or anything. Where is that image? It's an S3 object. It's in this bucket and the name is image. I think image is what? The key location, the file location. And we are saying only give me the labels which has minimum confidence 70. And then detector labels we are creating or initializing. What do you call it? Not initializing, yeah, assigning. Then we are checking the recognition labels. If this output from the recognition response, if it has labels tag, then loop through the labels and get the name or append the names in a lowercase to the detector labels array or list that we created here. Then we are printing the labels. And then we are saying if the label variable which we assigned airplane, if it is in this list of labels, then what do you do? Say success, label found, etc. Else failed. When we upload horse, since it's not there, this is going to get triggered. When we upload airplane, since it's there, this is going to get triggered. And try exception is a block. In case anything goes wrong in here, it will directly go to this and prints the error. Finally, once we have that output file, whatever we put it, wherever we put it, this one, but this is storing in the Lambda. No, not yet. It didn't have yet. Okay, so we are going to go to bucket. Output key is that location we gave output folder slash that, and we are saying whatever response you stored it here, right? Response status and the body, etc. I guess it is here. Put it in this body indent 4 etc. and put that in the S3. So we are just like uploading the file, then return the response. Pretty much that's it. I think we'll use this code for DIY. So that's what the code is doing. Before moving, we need to do some configuration changes, which is this needs to be changed to at least 1 minute. 3 seconds is fine. Save it. And also we need to change the runtime configuration. Let's go to code. And then here you will have runtime settings, edit them because usually this is the default, nobody will change it, but they changed the file to index. I'll show you where it is. This one. Usually you will leave it as is, but it's up to you. Since you changed it, you need to change it there as well. So I think pretty much that's it. So let's go ahead and deploy it. We won't test it because the S3 event which will be added here. You can add the trigger here or you can go to S3 and add it from there as well. Doesn't matter how you do it, both the same. But let's do it from here because we didn't yet create the bucket. So save. Okay, this sometimes this takes multiple hits. Okay. So let's go ahead, create a bucket and let's create a unique bucket and let's call this one. And as you already know, bucket names has to be unique. 1, 2, 3, 4. I don't know if that exists or not. It will complain if it. Let's enable ACLs. Objects in this bucket can be owned by other accounts. Access to this bucket and its objects can be specified using ACLs. Object ownership, we will give it to the writer. Whoever puts the files, they will become the owner. Versioning, we don't need it. We are leaving SSE as is, bucket we are defaulting. And yeah, there is a question that was asked as part of Cloud Practitioner, not Cloud Practitioner, I think it is Solutions Architect. They're planning to lock the object, etc., and also stop deleting it. So another option is versioning. Yes, object lock does require versioning. I'm just going somewhere with it. This is not related to this project, but I'm just explaining you guys if you're confusion. Object lock by default requires versioning. So people will think you need to have versioning enabled as well. But if you enable it here, it will automatically enable the bucket versioning. So if I click this, even though I didn't select it, it enabled it by default. Do you get that? So you don't have to do it twice. That is the question. So many people got confused about it. That's why I'm explaining it here in case if you are confused as well. Now we have the bucket. Let me close this. Let's go to the bucket and let's create the folder called input. Let's create another folder called output. Okay, cool. Now let's go ahead and create the events, right? Okay, so where do we have that? Somewhere here. Okay, let's create two events. The first event we'll name this one JPEG because that's what. And where do I want? On input and dot JPEG, exactly however they are showing it. And I want it to be created on put. There are so many events that you can select. And it's going to be lambda function I'm triggering. And what is a lambda function? I already have it created here, which is a lambda function. Then save changes. Similarly, I'm going to create another event. This time it will be almost similar, but this is going to be PNG. This is going to be input as well. And this is going to be .png. So in case there are any PNG files put into input folder, then trigger the event and trigger the lambda function. Save changes. Done. Now, if I put the horse file in here, let me upload it. Okay, so let's upload. It's uploaded. So behind the scenes, what happens? An event, since this is a put event, it will trigger the lambda function. Okay, it will trigger this lambda. If I refresh this, there will be a trigger because since I created it, it will pop here. You see that? Now this might have got triggered, but I don't know. But you can click on monitor if we have access. Let's see. If I go here, it should show me the logs that got triggered, etc. That is one way to see it. Or if you are too lazy to do it, you can just go to the S3 and we have an output bucket, right? Let's refresh it. Okay, this was supposed to be created, but it is not created yet. So let's see what is going on. Okay, it's not exist, so I cannot see. Wow. So they didn't create it, so that's fine. I think all we have to do is wait for, let me see. Don't tell me the lambda didn't get triggered. Why? Okay, this is interesting. It is here. The code is here. Mm, okay. Oh, okay. Did we miss anything here? We changed everything, right? Pretty much whatever we need to. Yeah. So let me check one more time. It didn't trigger it. Okay, one more thing. Let me check. Okay, I don't see why it's not. Let's go back. Let's check one more time. I don't know if it takes time. It shouldn't. It's basic. Okay, it's definitely not triggering. Let me check. Okay, I don't know what happened. I just deleted the file that we put in previously and uploaded the file again. And you can see I just uploaded it like 33 and 33. We got the response. I don't know. Maybe it took some time. I don't know. But did we put horse file before or after the? I have no clue. Anyways, that's what happened. I have the file downloaded. Let me go and open it and show you. So this is the response we downloaded, and as you can see, it makes sense because that's a horse picture. It has grass, and if you want me to open the horse picture, this is how it looks. Okay, it has puppy, a dog, horse, human, cap, jacket. I guess it will show us all those details. Oops. Okay. Let me minimize this. Let me close this. How do I do that? That's weird. Okay, that's fine. Okay, that's good. Now let's go ahead and upload another file, airplane. And as soon as we upload, it is very fast. How fast it runs is even unbelievable. So it's uploaded. So if I go to here, you see it immediately. That's too fast. Let's download it again. And let me open this file again. And you can see success, airplane found, and it has airplane and other labels. And it will only show us where the confidence is greater than 70%. Okay, so far good. All right. I think pretty much that's about it for the practice labs, wherein we created two events and two events successfully got triggered because one of them is JPEG, another one is PNG. Both worked successfully. So, okay, good. I like it. Now let's go and do the DIY. And they're asking us to update the Lambda code to detect a new label called spaceship. We can just go ahead and write spaceship. Upload the sample spaceship image to the bucket, validate the response file. We can do that. So let's go ahead. And I don't know why do they have this code? Let's see what it is. Oh, to create a test event. Okay, I'm fine. Let's go ahead and change the label to, where is it? Spacecraft. That's what they want us to name it, right? Spaceship. See? That's why we need to make sure spaceship. I think that's the only change here. And that's the DIY they gave us. Maybe it's the first project, that's why. But it's okay. I don't mind. Upload. Let me add. I have it here. Upload. Close it. Let's go to here. Output 37. Download. And this should have success spaceship found, which is the case. All right, nice. What is my bucket? Did they ask my bucket name or URL? Bucket name. I think let's give it. And if it shows green, which means whatever we did worked. If it is orange, means something is not right. And of course, it is green. I'm happy. Spaceship was detected in the image that you provided. Now return to the city, give the good news. So let's go ahead. They will automatically close the lab, so we don't have to worry about it. I, I mean, it's not too much advanced, but I think this is the first projects. So I hope my goal is after doing these 15 projects in this, they should at least teach me the process of what a machine learning engineer does on a day-to-day basis, right? That is something that you cannot read in any book. So if they are going, these are real-time projects, obviously. They're just replacing the images and etc. with spaceships and whatnot, but these are all real-time projects. Uh, So that's my takeaway from this entire series. If they are going to give me that, that's more than enough because networking the previous season, they gave me that. We are so grateful to you. Now we can identify UFS within minutes and sound our alarms much faster. So indirectly, they are UFS or like burglars or dangerous people around our home. Awesome. I'm glad I could help you. We are very excited about your solution. Choose your reward. Okay. I think this has a saucer, flying saucer. I'll pick that one. Okay. So I think that's about it, but this is not the end of it. Wait for some time. So after each project, there will be a quiz session wherein they are going to ask us questions related to whatever we have done, just to like a review. And what I do is I want to compete it with you all. Okay, so I was doing it, you are watching the project, so we are at the both level. So let's do this together. They will ask us 5 questions related to the technology that we just used, which is the recognition and etc. So let's go ahead and do those. And how it works is I'm going to zap these blue drones. So there will be 2 types of drones. I think that's an orange one. Orange. Okay, we have shortage of blue drones. Then they are going to ask us a question. Okay, now pause your screen, answer your question, then I will answer mine. I will give my answers. Then we will check whose one is right. If you get one, you got 1 point. If I get one, I will get 1 point. So after finishing 5 questions, you need to leave in the comments how much you scored and how much I scored. Why do you have to put my score? Because you will be seeing this video after 2 weeks of me posting. So I won't remember my score. So put my score as well as your score, then we'll see who wins. Okay. Which Amazon recognition APIs can be used to detect inappropriate or offensive content? Oh, they didn't teach us that. Select three. Hmm. They didn't teach us that. I think I will just go with this. Start content moderation. I don't think. Let's click on the documentation. Need a hint. So it's showing it as detect moderation labels. You can use the video API to detect such content synchronized by using start content and get content. Okay, wrong. I don't think there is anything called label detection inappropriate. Is that it? Yep. So mine gone wrong. Zero. Zero right, one wrong. So 0, 1. Okay, let's go one more. I think looks like one here. Okay, it landed right on top of us. How does AWS, that's it, network firewall work within a VPC? I think it is between these two. Firewall is something that we did in the previous season, networking. Firewall operates at the subnet level within a VPC. Firewall is directly installed on the VPC. Hmm. I think it is this one, right? Let's check. Yeah, but is it installed here? Maybe the first one is the right, but I'll just go with this. Yes. 1-1. 1-1. I got it. 1-1. How are you guys and girls doing? I got distracted there. What is a stateful rule group in the context of network firewall? Hmm. These are all previous. This I'm not expecting these questions. Stateful. I think it is this, a set of rules that monitors the life cycle of a connection and inspects all packets for a tracked connection, right? Stateful makes sense. Life cycle because yeah, I'm assuming. Oh, I instead of clicking hint, I go, okay. 2-1. Okay. I'm not doing bad at networking. I'm not a network person. Okay, I'm very poor at networking, but looks like I'm doing good. Seriously? Which AWS service can add image and video analysis to applications to identify objects, people texting? Seriously, it's a free giveaway. 3-1. How are you all doing? 3-1, 3-1. Okay, let's do the next one. Amazon Recognition supports billions of labels belonging to common categories such as people and events or food and drink. Billions? Maybe. But do we have billions? Maybe false. Let's check. I don't know. Okay, let's see. I don't know. It's a true or false. We'll just go with what it's. Billions, I don't think. Okay, I'm right. 4-1. 4-1. Wow. Okay, looks like there is one here. 4-1. Which AWS resource do users associated with firewall endpoint when configuring network firewall? Which resource do users associate? I think it's subnet. 6-1. I think we are done with recognition questions, so I'm going to stop it here. But how much did I score? 6-1. How much did you score? Leave a comment and let me know. And I think that's about it, guys and girls. Thank you very much for hanging out here. And don't forget to hit the subscribe, like, and comment button. Like and commenting are must. So go ahead and do that. I really appreciate you all doing that. It really means a lot to me. Because of you all, the channel is growing and I'm happy because my content is reaching more people. Obviously I will be the happiest person, right? So go hit that like, comment, and do all that awesome stuff which will make this content reach for many people and it will help them obviously. So thank you. See you in the next video. Have a great day. Peace out.